Good afternoon, everybody. Thank you for coming. I'm Jacob from UBC.
Sorry, your sheet doesn't say Jacob.
It's okay. First, I want to say sunflowers are very important. Actually, they are the state flowers of Kansas. So I checked the legislation to see why do they want to make sunflowers their state flower. They said this flower is full of life and glory of the past. That's right. Sunflowers, glory of the past. They have homoploidy, hybridization, speciation. They have chromosome inversion, haploploidy, and anything you can imagine from evolutionary biologist perspective. And the pride of the present. So the cultivated annual sunflowers are the fourth largest in production oilseed crop in the world. So it's quite pride, huh? And the last one is a golden future. Maybe I think it's yellow, so it's golden future. Today I'm going to talk about the snowy sunflower, which is Helianthus niveus. This subspecies is adapted to drought areas in habitats. So, as the annual cultivated sunflower is cross compatible with some close related relatives, so it is impossible to integrate some useful alleles to the cultivated sunflower. So, studying its genetic diversity is kind of useful to sunflower's oilseed production. Traditionally, this species includes 3 subspecies. This one is Tephrodis. It is perennial and grows on sand hills, occurring in southern California and western Sonora. The second subspecies, Connexus, is an annual species. It is taller and it is distributed from New Mexico to southern California. Interestingly, in its eastern distribution area, it is sympatric with another species, which is Helianthus petillaris. When they are sympatric, their morphology is very similar. So in some treatment, actually this subspecies belongs to petillaris. The third subspecies is niveus. It is endemic to Baja California in the coastal areas. In a 2016 trip to collecting wild sunflowers, we found 2 new morphotypes from Baja California. The first one we call it Nanatus. It's a fancy Latin name for hairy. You can see from here they're very hairy in the flowers and leaves. And also it is annual and it's erect instead of a normal niveus, which is decumbent at perennial. The second one is we call it rugosus because it has ringed leaf margin. Also, it has a little higher flowers than normal niveus. So, based on those facts, my research questions are: what are the relationships among specific taxa of the niveus? The second one is what are the status of the 2 new morphotypes? And the last one is why subspecies Connexus resemble petillaris when they are sympatric. It is secondary hybridization or it is a primary intergradation. So to resolve these questions, the first thing we did is morphometric analysis. We collected seeds from 10 natural populations from US and from Mexico. We collected a total of 10 populations, each with 5 individuals, so a total of 50 individuals. And we germinated the seeds and grow in a common garden experiment in greenhouse with totally randomized design. When the plants begin to flower, we phenotyped those plants, and these are some of the important traits that can be you can see from the results that the measurement is kind of similar to what you can see using your eye. Kinesis and Nathanus is erector, and Kinesis and Tephrodis has larger flower heads. And also Kinesis and Tephrodis have earlier budding date. They turn out to flowering earlier than the other three taxa. And of course, Nathanus has very hairy flowers. And the PCA also confirmed the results. You can see Kinesis and Tephrodis form the white cluster from all other three taxa from Baja California. So from this, we can see Kinesis and Tephrodis seems separated from all other Baja California populations. And we also did a post-zygotic reproductive isolation experiment to test the pollen viability of FY hybrids between different taxa. This figure summarizes the results. You can see Nevius and the two new morphotypes. They are all from Baja California. They didn't show a significant decrease in the pollen viability. But subspecies Kinesis and Tephrodis, they failed or showed a significantly decreased pollen viability with populations from Baja. Between Kinesis and Tephrodis, there's a slightly decrease, but not statistically significant. The third part is about genome size. We estimated the genome size using flow cytometry for each session. Still, we can see that Kinesis and Tephrodis has significantly smaller 2C value than populations from Baja California. However, this change is not there's no ploidy level change. It's just a significant 2C value increase. Okay, finally, I'm going to talk about population genomics. The GBS data. We constructed two GBS data sets. One is for the population structure, and the other for phylogenetic analysis. The population structure data sets includes 50 samples, and phylogenetic data sets includes another 27 outgroups. The structure analysis showed a very clear geographical pattern. We can see when case 2, Kinesis and Tephrodis are separated from others. When case 3, populations from Baja California begin to be separated. And when case 4, which is the best key value, the Baja populations form their own cluster. So it seems that there's a isolation by distance geographic pattern here. So we tested it using a metal test. The results is very significant. We have detected a clear isolation by distance pattern here. This is the phylogenetic construction. This is the second data set. We can see that all taxa, specific taxa of Nevius form one monophyletic clade. And Kinesis and Tephrodis form the Y clade from others. Interestingly, the two new morphotypes, Nathanus is monophyletic, but Rugosus is not. Finally, we have performed a Baba test to ask the morphological similarity between Kinesis and Pedillaris. You can see there are white beard in the middle of the flower head. The morphological similarity is due to introgression of those materials represent the primary, the ancestral state. This is a four-taxa framework, P1, P2, P3, and P4. P4 is an outgroup. P1 and P2 is two allopatric populations from Y species. P3 is another species, but sympatric with P2. If there, if incomplete lineage sorting is in the action, we will observe the same number of ABBA and BABA, right? So the results turns out that the d value is significantly larger than 0, and we also calculate FD, which is a proportion of genome that might be infected by introgression, which turned out to be 17%. So I think we have enough evidence that the introgression has played a role here. Okay, to conclude, the first, geographic isolation is primarily responsible for intraspecific genomic divergence within Helianthus niveus. The second one is niveus is currently circumscribed, should be considered to contain two species. One is niveus and another is tetralis. The two new morphotypes from Mexico represent local ecotypes of niveus, may be adapted to drought. And the introgression is responsible for the morphological similarity. With that, I would like to thank my supervisor, Loren Rieseberg, who is holding a trunk of Helianthus agophylis, I think. Also, Kay, for the help of the GBS data. And those who are not in the picture, Dr. Ivana, Dr. Diane Birch, Kelly. Also, I want to thank Genome EC and Genome Canada for the research, financial support, and CSC, China's National Council, for my support in my stay in Vancouver. Thank you. I'd like to take any questions.